This conference will now be recorded.
Hello, everyone. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 107. The title of today's presentation, USGS Landsat Science Products. I'm going to be your facilitator today, Jordan Girth from the Office of Observations. Our presenter is Andrea Lloyd, Science Communicator for the USGS Landsat program. Just a few reminders before we get started that this session is being recorded. As you just heard, there will be an opportunity for Q&A after the presentation, and we're particularly interested in questions from our field offices and regional headquarters. If you haven't signed in with your full name, when you ask a question, please note your name so that we can get back in touch with you if we need to do so. We're always looking for future presenters. Please contact the TowerS team. And if you need any training materials, Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank the TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, and the GOZAR JPSS programs for their support of the Satellite Book Club. And thanks to all of you for being with us today. You may have heard in previous presentations about storm damage and burn scar assessments and analyses. In particular, Joanne Cullen and Daniel Lamb from the Jackson, Mississippi Forecast Office presented back in February of 2021 on utilizing satellite data to enhance storm data assessments. Their presentation and many since have highlighted the interdisciplinary nature of the Weather Service mission and our use of satellites from outside NOAA's portfolio. So we're excited for Andrea's presentation today. Andrea Lloyd is a science communicator for the USGS Landsat program focused on creating web content to showcase Landsat data capabilities. She earned a bachelor's in Telecommunication Media Studies from Texas A&M in 2019, a master's in advertising at the University of Texas at Austin in 2021. Andrea is passionate about space science communication and science literacy. So we're glad to have you today, Andrea. Thanks for being with us at the book club.
Happy to be here. Go ahead and get started.
Take it away.
Thank you. So this Saturday marks the 50th anniversary of the first Landsat satellite launch. Since 1972, Landsats have captured the land surface of the Earth, allowing incredible uninterrupted imagery of the changes of our planet. Current Landsats image the same spot every 16 days. With Landsats 8 and Landsat 9 in orbit, a complete observation of the Earth is made every 8 days. The USGS creates Landsat science products to ease the data processing burden of the user community. These products are matured into the highest quality possible, allowing researchers more useful results for land change and land use analysis, especially over time. All of these files can be brought into any GIS software. So to start out, we have the Level 2 science products. Level 2 science products are generated from Landsat data. These products are designed for time series observations. Each product reflects sufficient length, consistency, and continuity to record effects of land and climate change. One such product is the Landsat Surface Reflectance product. It measures the fraction of incoming solar radiation. It measures the fraction of incoming solar radiation reflected from Earth's surface to the Landsat sensor. Surface reflectance improves comparison between multiple images over the same region by accounting for atmospheric artifacts such as aerosol scattering and thin clouds. The removal can help in the detection and characterization of the Earth's surface below. Our next satellite or science product is the Landsat Surface Temperature product. This product measures the Earth's surface temperature in Kelvin and is useful for monitoring crops and health vegetation, along with extreme heat events like volcanic eruptions, wildfires, and other natural disasters, and urban heat island effects. Any analysis that needs surface temperature can use this product, whether you're using individual imagery or you're looking at a series of images for a change over time. Both of these two products, the surface reflectance and Landsat surface temperature products, are inputs for the Landsat USARD, or Landsat Analysis Ready Data product. The USARD significantly reduces the magnitude of data processed by researchers before beginning investigative analyses, especially for time series. As the name implies, these tiles are only available for the conterminous US, Alaska, and Hawaii. From there, the level 3 products are generated from these tiles. Level 3 Landsat science products represent biophysical properties of the Earth's surface, like fire, snow, and surface water. Depending on the product, imagery is available for all 50 states from 1984 to present day. The dynamic surface water extent product, as seen here, also, the Dynamic Surface Water Extent product, also known as DSWE, describes the existence and condition of surface water extent and surface water along the coast and the continent. The DC product describes the existence, surface water extent affects weather and climate, stream networks, and geological processes. Land use, ecosystems, and water management in general are also impacted by changes in surface water extent. Aquatic scientists and water research managers require information on the dynamics of surface water. Some potential uses for DSWE include applications in habitat assessment, wetland monitoring, flood mitigation and recovery, and water resource management in general. Another level 3 science product is the Landsat Burned Area Science product. What it does is represent burn classification and burn probability on a per pixel basis. Accurate data from fire locations and burned areas are required to quantify fire trends and fire behaviors. The Landsat Burned Area product is designed to identify burned areas across all kinds of ecosystems, including wetlands, forests, and prairies. Applications for the Burned Area product includes fire management, fire evaluation and prediction, wildland resource management, and fire hazard evaluation. Our last level 3 product listed here is the Landsat Fractional Snow Cover Area product. What it does is indicate the percentage of a pixel covered by snow. Snow cover is spatially and temporally variable and is often concentrated in remote, inaccessible land regions that are unavailable to people, making spaceborne remote sensing the most feasible approach to measure and monitor snow cover changes. Landsat's spatial resolution offers the capability to recognize snow cover patterns across topographically complex mountainous regions. Potential applications for this science product include snowpack analysis, drought monitoring, and water supply management. From there, I wanted to share where you can access these science products. Using Earth Explorer, all of the previously mentioned Landsat 2 and Level 3 science products can be downloaded from USGS data portals, including Earth Explorer and the Amazon Web Services cloud platform. Earth Explorer is the USGS's one-stop shop for geospatial datasets from several different collections, including Landsat satellite imagery. All Landsat satellite data and previously mentioned science products can be downloaded immediately from the Earth Explorer website. The last 3 products I'll mention are on ESPA. And ESPA stands for the USGS Aeros Science Processing Architecture Interface. And here we host provisional products, which, unlike the standard products that I mentioned, provisional products are subject to revision. They are being provided to meet the need of the user community for timely best science, but the data has not received final approval by the USGS. ESPA is used to request on-demand processing of certain Level 2 and Level 3 science products, as I'll describe. Unlike Earth Explorer, these cannot be downloaded immediately, and you'll have to wait for the data to be processed before downloading the science product. And the 3 science products that we have in ESPA available is the Landsat Surface Reflectance Spectral Indices. They combine different surface reflectance from 2 or more Landsat spectral bands that help indicate features of particular interest. Popular ones include vegetation, water, and geologic features. Two of the most commonly used topics with these indices are vegetation analysis and burn ratio. Vegetation indices, as you can see here, with the moisture index, the vegetation index that was just shown, is helpful for assessing vegetation density and changes in plant health, such as crops and forests. These can be used after hailstorms, derechos, and droughts to understand damages that occur from extreme weather events. Burn ratio indices also indicate burned areas and burn severities, like this one here. These are especially used in post-fire recovery studies. Our second provisional science product is the Landsat 8 and 9 Provisional Aquatic Reflectance product. It is used to measure the spectral distribution of visible solar reflected radiation upwelling from the upper water column. This product can make contributions to aquatic science and environmental monitoring capabilities for aquatic ecosystems, especially coastal environments and inland water bodies. Examples include temporal phenology and water quality monitoring. And the last product that is Landsat product that's available to you on ESPA is the provisional actual evapotranspiration science product. This one measures the water that is removed from the surface due to evaporation and transpiration. It's useful for understanding crop and vegetation health in general. It can also be used to understand before and after effects of an extreme weather event. Lastly, I just wanted to add contact information that's available to you. More information on Landsat, Landsat science products, and Landsat data products can be found on our website, which is www.usgs.gov/Landsat. Users are also encouraged to contact USGS customer services with any questions that you might have. The email address is listed here.
Okay. Thank you so much for your presentation, Andrea. We'll now have opportunity. Hope you can stay on for a few questions. I'll start off with the first question, but if anybody else has a question, please go ahead and drop it in the chat and we will field them through there. My first question is, are there any restrictions on the use of Landsat data?
There is no restrictions on the use of Landsat data. It is freely available for the public, and there's no restrictions. You can download it at ease, and you can use it for your research and for creating imagery, all sorts of things.
Okay, great. So one of the things that our field offices have to deal with is having a weather event happen maybe a day earlier, and they're starting to assemble survey teams to go out into the field, or at a minimum, they're curious if there is damage out there the next day. So assuming that the skies clear out and Landsat is able to get a good image, a couple questions. First being, how easy is it through the portals that you just discussed to know when the most recent Landsat pass was for a certain geographic area or point?
So for the Earth Explorer portal, it's very simple. It's not zooming in, so I'll just play the video from here to the side. But you just type in the location that you're interested in, or if you have a longitude latitude point, you can put it in there. And then you enter the dates that you're looking at, So for this one, I was looking at Las Vegas. I think it was just in the past month or so. Once you enter the rest of the criteria, which Landsat you want, things like that, it will just pull up all the potential data that you can use. Let's see, it must be towards the end. And so right here on the left side, you can see that the image I was looking for pulls up, and it shows me where that image is located. I get a general look of what it looks like, but you can download it and access it from that point too. Did that answer your question fully?
Yeah, I mean, maybe just a couple follow-up questions. So one, does this take into account whether the scene was cloud covered or not? Does it know that, or does the user have to assess whether there was cloud cover?
So the user can put in how much cloud cover that they want in the image. So you can reduce it down to 10, 20% if you want, and that's for the whole scene, which is a 185 kilometer by 185 kilometer square. But the cloud cover will appear in the scene if it was there that day. But you can reduce your cloud cover by this cloud cover range tool that's on the Earth Explorer.
Oh, that's great. Thanks for pointing that out. The other question is I talked a little bit about, often our survey teams are out there, within a day or two of the event. How quickly is Landsat data processed and available after it's captured on your Earth Explorer sites?
I believe, and I know Michelle, you're on here. Correct me if I'm wrong. I know that Landsat 9 data, it is 24 hours after. Is that the same for Landsat 8 data as well?
Landsat data is available 4 to 6 hours after acquisition.
4 to 6.
Level products take a little bit longer, but there's a real-time product that's put out right away, and so that'll show up within 4 to 6 hours. And when you're searching, you can actually put the browse image up so you can see, even if it has cloud cover, if there's cloud cover over your area study. So that's one good way to look at it before you spend time downloading the data.
Oh, okay. That's good to know.
You can ask another question. I was just going to pull up a scene so people can see what it looks like.
No, that's great. Thanks for demonstrating this for us. So you're doing a lot of clicks through there, and this is actually kind of related to my second question. Is there a guide? We have so many acronyms here in NOAA. I'm sure you do over there in USGS as well. For our field forecasters, they may just want to look at this type of what we call a true color image. But they may not know that, where to go on the website. Is there a very easy way for them for people to kind of follow a process to get the most recent image for a certain time?
So depending on when you're looking at, so here I just have the last month of July. You can go to results, and then you can directly download the true color image right here. You will have to create a login. I'm not logged in to download it. But it's available directly to access right there.
And even if you don't put a date in, the last image will always show up first on your search.
Okay, so that's good to know. So they don't even
always be at the top.
Okay. So if they don't even enter a date, you're just going to get the latest image that's on there.
Correct. Yep.
Okay. Wonderful. Well, I see a question come in from A to Cars, if I'm pronouncing that correctly. Does USGS perform any data reduction prior to release as part of these science products?
I'm not sure what you mean by data release or data reduction, but we do bundle them into a tar file that can be unzipped. So if you're downloading the entire data set, it will come in a reduced size file that you unzip onto your system. Or if you download individual scenes, then you would not, it would just be the full file. Does that answer your question?
Well, I'll let the person that asked it in the chat type in if they have a follow-up. That would be great. I assume the question was maybe either with regards to some kind of compression, or maybe I know I see on the slide here that you got full resolution, but sometimes we in NOAA have reduced resolution products of certain types, so it doesn't sound like. Sounds like it's really easy to get the highest resolution data immediately from the portal.
Yeah, like a Landsat 8 scene is about 1.2 gigabytes, so it's not, super large. So they're pretty manageable.
Okay, yeah, that sounds good. Yeah, if there's any other questions, please get them in the chat here. I'll go ahead, and I just wanted to follow up a little bit more, especially as we head into fire weather season, about the burned area product, and if you had any ideas for how our field sites could use that particular product.
Sure. The burned area product is useful for understanding where a fire's been or how it acts. For example, this is one example of a burned area product. It shows in red here where the burn scar and where the fire's been through. I'm not as familiar with what the burn probability is. Michelle, if you can speak to that for a second.
It's just the percentage of a pixel that is probably burned.
Gotcha.
So each pixel is 30 by 30 meters, and it just describes the percent of that pixel.
Yeah.
So maybe if I could just ask a follow-up question about that, whether it's burn classification or burn probability. It says Landsat data acquired from 1984 to present, but after you have a burn scar, the recovery isn't instantaneous. So at what point does this product not recognize it as a burn scar anymore? Is there some kind of multi-year approach that's looking at the burn scar, and it's kind of always there until it's fully recovered, or does the burn probabilities get somewhere in between?
So this is just with the natural natural Landsat image. And so it's not using the burn product, but it'll help illustrate the burn scar. Here in 1988, you have a fire going through Yellowstone, and you can see the red area where the fires and burn scars are. And then this is later that year. Again, you can see the burn scars and fire damage very clearly. But over time, you'll get, this is 2011, so about 2088, 20 years later or so, 15 years later. And these brown areas are where those burn scars were, where the fire was. And you can see it healing with more vegetation growing back in and things like that. You can see the heaviness of the burn scars here as well. This is a previous year in 2003, so this is before the one I just showed. And so Landsat is able to detect the probability of it, or the burned area science product is able to use Landsat imagery to understand where the burn scars are and how it changes over time. So you can understand the probability of an area being burned and how it looks as it changes through time.
Okay, great. And does this product, I'll have to go back and look at the documentation to see spectrally how this is composited, but how about other kinds of damage scars? As I mentioned, we sometimes have straight line wind damage that can be evident through satellite imagery in agricultural fields. We can have tornadoes that go through heavily wooded areas, can create a signature. Does USGS have specific products that would help with those kind of others? See, there's the hailstorm there. Are those kinds of applications that are readily accessible through the portal as well?
The products we have is for burn scars, for flooding with the surface water extent. And then you can use the plant health to understand some of the other things. I don't know about straight wind, but for example, all this dark red is healthy vegetation. This down here, this blue is Sioux Falls before the hailstorm. And then after the hailstorm, all this blue is damaged crops and vegetation. So it's not directly looking at the wind, but by analyzing the plant health, you can understand the damage that happened to the land surface.
The on-demand spectral indices that we have would address that with the NDVI or EVI.
Mm-hmm. And those are available through ESPA.
Okay. All right. Well, I think I probably need to work with you a little more to see if when our TowerS team to get maybe a data guide available to our field office. There's certainly a lot of data here. I'd like to make sure that our field offices can figure out how to access it easily, because one of the challenges that we have working in an operational environment is we often have to move pretty quickly to look at new data sets, even after a storm goes through. So look forward to leveraging some of the Landsat mission data for operational uses here within the National Weather Service.
I sent Kashand, this is actually a website that we have about science products, but I sent Kashand this link and then a link on how to download the sets. There's a tutorial in there and some other links that can be helpful to people who's trying to get their feet wet in Landsat data and get started. So there's materials available, and you can always contact USGS customer services and we can help you get started and with information that you need as well, so you understand how to access it and things like that.
Okay, fantastic. Well, I really want to thank you for your presentation, and thanks for some of your colleagues for being on the line today as well. Kashad and Lee have posted in the chat not only the presentation materials, but the data access website. There's also a link for you to provide feedback, all of you listening today, on the Satellite Book Club seminar series in general. We would like your feedback on this session. Maybe you have additional needs for follow-up, and we'd certainly love to put you in touch with the USGS team. A week from today, we are going to have a special Satellite Book Club from the GOES-R Program Office and TowerS team that's going to preview special GOES 18 operations. That's going to continue at our normal time, 12 noon Eastern time on Thursday, July 28th. In the meantime, if you have any other questions related to the use of satellite data in AWIPS or the Satellite Book Club, please feel free to get in touch with Lee Byerly or Kashad Momin, John Evans, or through the NWS chat. We're available to assist you with anything regarding that. So not seeing any other questions, we'll wrap it up there for today. Andrea, once again, thank you so much for taking the time to present to us on Landsat. As my colleague Brian Gockel says there, it's a great mission, valuable data, and we're very thankful for your presentation today. Hope we will be able to stay in touch.
Of course. Thank you.
All right. Thanks everybody for coming today. Hope you'll join us again next week. Take care. Stay cool.